Hello, Jameson Exam Tuition. We continue again with our series on speed and accuracy in mathematics. Today we're going to focus on factorization, which is one of the tools that we use constantly in mathematics when solving problems. If I had 2x minus 4, a simple case, and I need to factorize at some point when I'm solving a problem, it simply means I should take out the common factor, which is 2, and to get what I will write in the bracket, I simply divide every term by the common factor. So 2x divided by 2 gives me x, and negative 4 divided by 2 gives negative 2. It could be negative 5xy minus 15y. Then the common factor would be negative 5y. And when I divide negative 5xy by negative 5y, I get x. Negative 15y divided by negative 5y will be positive 3. And so the answer is negative 5y into x plus 3. There are situations where you have 16x cubed y squared minus 64 x to the 5th y. In this case, we look at all the variables and the coefficients to see the common factor. For the coefficients, 16 is common, and for the variables, we take the lower degree as the common factor. So there is x cubed and x to the 5th. The lower degree is x cubed. There is y squared and y, the lower degree is 1. So we take y into 16x cubed y squared divided by 16x cubed y. 16 cancels 16. X cubed cancels x cubed. Y squared divides y to give y. And so we have just y left. Negative 64 divides 16 to give negative 4. And then x to the 5th divide x cubed to give x squared, and y divides y to give 1. So we are just left with y minus 4x squared as the factor in the brackets. We also have factorization of difference of two squares, very frequently appearing when we are solving. A squared minus b squared equals a plus b into a minus b. And you could have x squared minus 4 all over x minus 2 to simplify at some point. This gives x plus 2 into x minus 2 all over x minus 2, which cancels, and you are left with x plus 2. I could have the limit as x tends to 3 of x minus 3 all over x squared minus 9 to simplify or to evaluate. This would be direct substitution leads to the indeterminate form, as you have 0 over 0. So there is a need to use some method and simplify before solving. So we take limit as x tends to 3 of x minus 3 all over difference of two squares at the denominator, x plus 3 into x minus 3, and this cancels this to give limit as x tends to 3 of 1 all over x plus 3. And direct substitution gives 1 all over 3 plus 3, which is 1 all over 9. You could also have 4x squared minus y squared all over y minus 2x to simplify at some point. And up is difference of two squares. 4x squared is 2x all squared. So I have 2x plus y into 2x minus y all over y minus 2x. X minus y is the negative of y minus 2x. So if I cancel here, I have 1. Cancel there, I have negative 1. So the final answer will be negative into 2x plus y. We also have the sum and difference of two cubes. For the difference, a cubed minus b cubed equals a minus b into a squared plus ab plus b squared. A cubed plus b squared, sum of two cubes, a plus b into a squared, minus ab plus b squared. So you can see that the terms are similar except for the signs. The sign between the cubes appears in the first factor, but the opposite sign in the middle term of the second factor. So minus, minus, and then plus, 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 and then minus. We could have again a situation where we need to evaluate the limit as x tends to negative 1 of x cubed minus 1 all over x plus 1, or rather x cubed plus 1 all over x plus 1. And I'm trying to substitute directly, it leads to the indeterminate form. So we need to simplify, and the sum of two cubes comes up at the numerator. X cubed plus 1. 1 is also a cube. So x and 1 are involved. So I write x plus 1 according to the second formula here into x squared minus 1 times x, which is simply x plus 1 squared, which is 1, all over, this is tends to negative 1, all over x plus 1. And x plus 1 cancels. So we get now the direct substitution of negative 1 in the function left up, which gives negative 1 squared minus negative 1 plus 1. And we have 1 plus 1 plus 1, which gives 3 as the limit. Another expression that you would commonly come across when factorizing is quadratic expressions. They are expressions of the form where a should not be 0. Usually to factorize is one of the speed breaks when you are solving problems in mathematics. There is need to look for a shortcut for getting the factors as fast as possible. And a simple method of doing it is called the cross method. Consider x squared minus 7x plus 12. Or let us start with plus 7x plus 12. In this method, I go straight to getting the factors. In rough work, I will break down the first term, which is x squared into x and x. So x times x gives me x squared. And I will go to the last term, the constant term, and look for any two factors. I know there are quite a good number of factors that could, multiply to give 12. For instance, we have 3 and 4, 2 and 6, and then 1 and 12. But it will be a situation where the two numbers that I bring, for instance, I bring 3 and 4, and the choice will be based on the middle term in such a way that if I cross multiply and add or subtract the results, I should get the middle term. So if I have this situation, positive 3 and positive 4, crossing and adding, I will have 7x. And that means my factors are x plus 3 and x plus 4. So I write them down directly after that rough work, so that you don't waste time. The process might be slow now as you are still trying to get it, but once you have mastered it, it just becomes intuitive and you'll be getting answers, the factors very fast. Another example could be x squared minus 7x this time, then plus 12. If I go again, I have x and x at rough work. And the fact that I have but negative 7 now shows that there will be negative 3 and negative 4. So that crossing, I will have negative 4x and negative 3x. So that adding them should give negative 7x. You would have to test for addition and subtraction each time you cross. The one with the signs that give the middle term is then the one that gives the factors. And so the factors in this case would be x minus 4 into x minus 3. I could also have x squared minus x minus 6. So I will get the factors as x plus or minus some constant and x plus or minus some other constant. In rough work, x squared would simply be x times x, and negative 6 again. Since I have negative 6, one of the numbers has to be negative. And 3 and 2 can give me a difference of negative 1 in the middle here. So if I put 3 here and 2 here, for me to cross and have a negative sign when I add, I will need that the bigger of the two should be negative and then the smaller one should be positive. So if I cross now, x times positive 2 plus x times negative 3, I will get negative x in the middle, and that means the factors are negative x minus 3 and x plus 2. In another example, I have x squared plus 5x minus 24. Again, since it's just x squared, the first of the factors will have x and the second will still have x. In rough work, I get xx, and the factors of 24 with a difference of 5. One of them has to be negative, remember, since 24 is negative 2. And the sign that is in the middle would be taken by the bigger of the factors. The factors of 24, whose difference is 5, are 8 and 3. And for me to cross them and have positive 5 when I add, it means that 3 should be negative and 8 should be positive. So the factors will be x plus 8 and then x minus 3. In the case where you have 3x squared plus 10x plus 8. This time it is 3x squared as the first term. So there will be some 3x beginning one of the factors. and then x beginning the other factor. Now in rough work I put 3x and then x. I have to look for factors of 8 and place here. There is 4 and there is 2. There is also possibility that 2 should be up and 4 down in the case where the coefficient of x squared is not 1. You have to look at the switching of positions to be able to get the answer fast. If I do the crossings with the first two, I get 3x times 2, which is 6x, and 4 times x, which is 4x. Adding the 2, I get 10x. So that implies positive would be the factors 3x plus 4 and x plus 2. These other ones are out. So I get 3x plus 4 and x plus 2 as the factors. Finally, I could have x squared minus x minus 6 as another quadratic expression to factorize. I would again write directly 2x squared broken down into 2x and then x. If I go to rough work, I get 2x and then x, and the factors of 6 again, I could have 2 and 3 or even 3 and 2. And trying these, if they don't go, I would need 1 and 6 or 6 and 1. Let us look at these two first. 2x times 3 gives 6x, and x times 2 gives 2x. Adding 6x and 2x or subtracting them, I can never have negative x. It means it's not the pair I want. I move to the next pair. 2x times 2 is 4x, and x times 3 is 3x. Negative x, for me to add and have negative x, it would need that negative should be at 2 and positive at 3. So that 2x times negative 2 would give negative 4x, and x times positive 3 will give positive 3x. So negative 4x plus 3x now gives negative x in the middle. That confirms the factors. So 2x plus 3 and then x minus 2 will be the factors. And so once you have mastered this, you would see that your factorization of quadratic expressions goes very fast and within seconds.